if you're interested in applying or you want to read about the applicants or discuss their applications or ask them questions, that's happening over on the Zcash forum. And then the third announcement is we just concluded, or we're in the midst of a hackathon with Gitcoin. And so here are some highlights. So there were a bunch of different organizations and projects involved. For Zcash, ECC had this theme of protecting privacy with shielded Zcash. There were 8 teams that showed up and 4 submitted their projects. And so it's these 4 here. And we haven't yet selected a winner. I'm not sure who is doing the judging, but I think that's happening next week. And so, yeah, you should all check out these projects. I think maybe somebody from Zact is here. Is that correct?
At least one of the judges is Vitalik Buterin.
Okay, so we know the identity of at least one judge. But apparently it was a lot of fun, and the ECC wallet team also sort of participated even though they were not eligible for rewards to build their thing too. So yeah, it was good fun. Check that out. All right, let's move on to the speakers. So Loong, are you ready to talk about RenVM?
Yeah, sure am.
Go for it.
Yeah, so my name's Loong. I'm the CTO at Ren. And last month, I think maybe 5 weeks ago now, we went live onto mainnet with our cross-chain interoperability solution. So what this enables is Bitcoin, Zcash, and Bitcoin Cash to be used on Ethereum. And at the core, it's based on MPC cryptography. So we have a network of what is currently 1,000 nodes. And these machines are in charge of generating a private key in secret, which is able to take custody of certain funds. And then in return for those funds, they create a tokenized representation on a blockchain of choice. So for example, in the case where you might send Zcash to RenVM, it would give you the ability to mint a tokenized representation of that Zcash on the Ethereum blockchain, and you could use it. And we've done, I think now $33 million worth of volume since we launched, averaging at about 1 million a day. The vast majority of that has been RenBTC, but we're really hoping to push for RenZcash, because I think there's quite an interesting use case, especially since we should be able to continue some of the privacy features once you get something like RenZcash onto the Ethereum blockchain. And so it would be really cool to be able to see these kind of interoperability bridges that can still maintain a level of privacy. At this stage, RenVM doesn't yet support Z addresses, although we're kind of looking into how we might do this. It should be, in theory, once you have the ability to do private transactions on Ethereum using something like Aztec, you should be able to go from a Z address to RenVM and then straight back to sort of an Aztec node and maintain a similar level of privacy. Yeah, so I think the main Zcash that we see on Ethereum right now is put into a Uniswap pool, but we're hoping to do some incentivized programs in the coming months to get people to put more Zcash on Ethereum and put it to work there.
Awesome, thanks for sharing. So are there ways open source contributors can get involved?
Yeah, so soon we'll be open sourcing. So I managed to convince my business team to let me begin open sourcing parts of our code base. So we'll be doing an incremental open sourcing of various parts of our code. So open source contributors can come in and check it out and obviously give us some feedback and let us know if they find any problems. We hope this is a good compromise between being able to get the security benefits of having more eyes on it without the security risk of suddenly open sourcing the entire code base in one go. The other thing is that we'll be open sourcing our multi-chain environment soon, which I guess is not super relevant to the Zcash team, but what it will allow people to do is come in and provide integrations for their own chains. They won't get accepted straight into RenVM because there's a governance process that needs to take place. But for example, if someone in the Zcash community was super keen to see Zcash on Substrate or Ava or any of these other up and coming chains, then in theory you could come in and you could provide an implementation on our multi-chain, and that would enable at least a demonstration of that technology, and then it would be up to governance whether they accept that onto the mainnet or not.
All right, thanks. That sounds pretty exciting. Let's move on to the next. Let's see, we have Henry de Valence from the Zebra developer team.
So what I'm here to talk to everyone about today is Zebra, which is a very exciting project that we've been working on for quite a while, which is trying to build a really modern and high quality Zcash implementation, basically from the ground up. So at least the way that I think about the way that Zcash works, you have this sort of like beautifully engineered like rocket engine, which is the sapling cryptography. And it has like incredible privacy benefits, and it's very well engineered. And this awesome, like precision engineered privacy technology is sort of like bolted onto the end of this like clanky 60s rocket. And that is the like Bitcoin source code. And for kind of unfortunate historical reasons, the Bitcoin source that is in Zcash is even from before there was kind of a major refactoring, because that happened after Zcash forked. And so that's kind of a drag, because it means that Zcash is like difficult to develop, and it's also difficult to work with. If you want to sort of build something that uses Zcash and somehow interoperate with the Zcash chain, you have to sort of spin up this whole piece of software and then figure out how to like poke it in the right way to get what you want. And there's also issues with the kind of architecture of Zcash, like the sort of the ping and reject attacks from last year. One way to think about those is as being a sort of like localized, oh, there was a problem in this sort of exception handling in this function. But really, the kind of bigger picture issue there is that the Bitcoin software architecture was never really designed for privacy. And so this project is sort of trying to fix this by making a kind of library first node implementation. So that's a pretty common kind of architecture, at least in Rust, where rather than just making a binary, you make a collection of libraries, and then you have like, you know, essentially a main function that calls into them. And hopefully all of these libraries that we've made will be kind of independently useful for other projects that want to kind of inspect the chain or work with Zcash data. So just to kind of give you a little tour of some of the stuff that we've been working on, the most complete part is the Zebra network crate, which provides a really, really cool abstraction for communicating with the Zcash network. So in the Bitcoin networking protocol, there's sort of like all these messages that fly around, and in order to interpret what a message means, you have to have a whole bunch of contextual data. And we actually encapsulate all of that into a single sort of per connection state machine. So every peer connection is isolated from every other peer connection. And when you use the Zebra network crate, you just kind of call init, and it, you know, hands you back a thing that you can make requests to. And those requests get load balanced over all of the available peers. It automatically does all the crawling and stuff. And so if you want to kind of make a tool like an observatory that has to crawl through the network, this would probably be useful. We have a whole crate with definitions of chain data structures. One thing I'm particularly proud of is our representation of what is a Zcash transaction. And instead of trying to sort of as closely represent the bytes of the encoded transaction as possible, we represent an internally parsed structure, so that a lot of the consensus rules about like what fields have to be present in a transaction in what version are actually not something that we have to check, because it's just impossible to incorrectly represent them. You would just get a compile error. So for instance, you can notice that in a version 2 transaction, there's this join split data with a BCTV14 proof. And in a v4 transaction, it's join split data with a GROT16 proof. So it's actually just impossible to like make the wrong thing. And that's very cool and fun. So I don't want to kind of go into all the details, but just this is hopefully quite exciting as a set of kind of reusable libraries for working with the chain state. Our goal is that these libraries should be useful for other projects other than, you know, obviously we're working towards our node implementation, but hopefully they should be useful for others as well. It would be great if people who are working on various ecosystem projects kind of check out these docs. They're at doc.zebra.zfnd.org and see whether any of these components might be useful. There is a caveat that a lot of this stuff is still unfinished. So it's not that I have a kind of thing that is immediately ready to go, but hopefully this will be a solid kind of grounding for projects in the near future. We're hoping to be able to fully sync the chain within the next month, and we have some very cool and exciting kind of like asynchronous batch processing of all the blocks and everything coming down the pipe. So we have on our issue tracker, which I think I'll just pull up.
Cool.
This is our issue tracker. Feel free to kind of come in, hang out. We have a Discord too. Sorry, that was supposed to have been the conclusion. I just got
awesome.
Carried away.
Next up, we have Chili Bob.
Hello, everybody.
Go for it.
Okay. Of all the projects that people are talking about, this has to be the simplest one because it's about 400 lines of Perl and that's it. And all it does is it hangs off the back of a node, receives memos, and does something with them. But it was really just an experiment to see what happens if you connect something which is, you know, anonymous and private, and then broadcast it to everybody, like the Zec pages people are doing. Anyway, so far, not much has really happened. It hasn't exploded into some huge torrent of spam, and it's all kind of quiet. So, QR codes, scan it with a wallet, and it works with Zec Wallet and Nighthawk, and even with Ycash, their YSimple wallet, that works too. And what I did, I have the two nodes, a Zcash node and a Ycash node, and I put them back to back, which means you can take a memo from Zec World and you can run it through this gateway and it will deliver it to a Ycash Y address. Or it'll go to an email address or to everyone, Twitter, Telegram, Reddit, whatever. And it's really quite simple. So all it does is it just listens for the wallet notify, which gives it the transaction ID. And you then have a little script that runs through all the transactions for that address, decode the memo, and do something with it. The new thing that's come out in the last thing on Zcashd is view transaction, which instead of having to run around and look at every transaction, I just give it the TXID and I get exactly what I want. So that's in the Zcash world, but not in the Ycash world. So things are diverging a little. But as a little experiment to just see what you can do with these memos, it's kind of fun. And so this is what you get. all of these things have an API which you can just throw messages at it and it will go into Twitter or its own little subreddit or into Telegram. And that's really it. Something that came up, which I don't know if it's covered elsewhere or it's already been done, is the structure of these memos. It's kind of a free-for-all, and maybe it shouldn't be. I found zip 302, which is talking about how to structure data in them, but there's all different sorts of data that you could have there. And we're already diverging a little bit. I mean, the ZECC wallet uses sent to as a tag and then follows it with the address of the wallet that's sending it, whereas Zec wallet uses reply to. So we're already diverging a little, and maybe we need a bit of a harder standard. And the other random thought that came out of all of this is if you just wanted to use Zcash for messaging, then you can cut the transaction expiry time down to the absolute minimum and the mining fee to the absolute minimum, which means the transaction probably won't get mined and it will get booted out of the mempool, but obviously the mempool broadcasts it to everybody. So it's kind of maybe a useful accidental mode for it. So that's Gateway XYZ. I will put the code up on GitHub once it's a little less embarrassing, and then anyone else can play with it. And this is just a little sneak preview of my current project. And that's it.
Awesome, thanks. Next, we have Holmes. Holmes, do you want to screen share?
I will, and so I will as soon as you're off.
Yep.
And here. So yeah, I just wanted to give a quick overview of what we're doing on ZBay. A quick introduction for those who don't know us. We're making a messaging app based on the encrypted memo field that also lets you send money to people and buy things and post things for sale. It looks like Slack, and it sits on top of a full Zcash node. You can try it out at zbay.app. I'm going to post links into the chat right when I finish. So this is what we've been up to recently. We're now in public beta. We have a group of mostly Zcash early adopters and some friends of mine hanging out and testing the app, which is great. We have a new website. We launched with a very manifesto-y essay on everything, about why the project started. And now we have something a bit more digestible up there. And we've moved issues and roadmap to a public GitHub now, so people can see where we're going and what we're doing. And it's easier to submit issues because you can search for whether an issue is known to us. And we even have now a demo store channel where I've posted some items for sale, like a Zcash branded ski mask and let's see, a few other things, some Zcash branded socks and some other stuff. So alpaca socks also, which is kind of a classic like OG Bitcoin e-commerce early adopter item that folks are selling from the actual farm that was the farm that was the first to sell alpaca socks on Bitcoin. So anyway, that's happening, and I would invite everyone to try it out and see how it works. The big news for us going forward is that we've had a Zcash Foundation grant approved. It's a little over 63K over 4 months to focus on making ZBay a suitable secure messaging platform for journalists and activists. Thanks a lot I wanted to thank Josh Cincinnati at Zcash Foundation and Sarah Jamie Lewis at Open Privacy for feedback on the grant proposal, and we're super excited this is happening. It's just kind of amazing that this is possible, and it's extremely exciting that the MGRC stuff is unfolding and developing as well. And so as part of that, pretty much almost all the work we're going to be doing over the next 4 months will be focused on executing that grant. That's going to mean like client support. Right now, ZBay uses a full node, and we do it in a way that syncs actually pretty quickly, like an hour and a half or so on most computers, but it's still way too much. And there's this crazy disk space requirement where you need 25 gigs free to run ZBay, which is not great. So we already know that's a huge usability problem for any normal person. So we're going to be focusing on addressing that. Then we're going to be concurrently doing interviews with journalists and activists about their existing needs in the space and doing threat modeling based on those interviews. And then the remainder of the work will be, on the dev side, will be mitigating the threats through identifying the threat modeling process. So that's pretty much all what we'll be doing. The remainder will be continuing to fix known bugs in ZBay and improve our development process. So just like working on things like CI, deploy process, where we added a QA, we onboarded a QA, a part-time QA person recently. So we're still working on stuff like that, but almost all the work is on the new grant. This is the timeline for the different phases of the grant, and I'll post a link to the grant proposal so you can learn more about what we're doing there. For asks, the most helpful thing for ZBay as it stands right now, and for the Lite wallet work we're doing, would be prioritization of Zcash and Zec Wallet Lite CLI issues. And I have a running sort of meta ticket in our issue tracker. Pardon me. I have a running meta ticket in our issue tracker with links to issues in Zcash and Zec Wallet Lite CLI, and I'll post that to the chat as soon as I'm done. So it'd be awesome to get people's eyes on those. And we're also really interested in being included in any conversations that are happening around anonymity, network layer privacy, or protection against dusting attacks, really anything that affects anonymity and privacy. It'd be awesome for us to be included in any of those conversations as they're happening, just so we can kind of keep our eye on where everyone's heading and what work is happening in the field right now, as we figure out how to solve those problems for the users that we're interviewing. So yeah, and then the last ask would just be to try out ZBay. It's cool, it works, and I think in tomorrow's release, the store will be included. Right now, you actually have to join it. It's a channel called Store, but you can try out buying something over Zcash with a reasonably intuitive interface and no dependency on any other infrastructure other than the Zcash network. So it's pretty cool. I think that's it for me. I'll start frantically pasting links to the chat to accompany some of these things, and thanks.
Awesome. Yeah, thanks for sharing. That sounds exciting. By the way, I just started syncing my ZBay app about 30 minutes ago, but I decided to pause it during this meeting just in case there were bandwidth issues. Cool. All right, next up. This time I'm not going to share my screen. I'm just going to say that it's Mitchell from Zcash Observatory, and then ask, do you want to share your screen, Mitchell, or do you want to? I do. I can throw up the slide. Okay, great. Look at that.
Can you all see that?
Yep.
Okay, great. I lost Zoom, so I'll just talk in general. 5 minutes, right? Okay.
Yeah.
So thank you. So I'm sharing some updates about the Zcash Observatory. Checked in briefly in May about this and wanted to share some updates about the work we've done since then. I'll do a quick recap of why we care, then I'll show you how to use an observatory node, I'll show some results from our recent analyses, and then I'll give an overall update on the project. So the motivation recap is the Zcash Foundation had this great list of items that they wanted, about 6 of them bundled together very nicely into what we call the observatory feature set. And so we decided to take these, implement them into the node, and then put a bunch of these observatory nodes together into a larger network, which allows us to do a couple of things. Get a big research database, queryable SQL analysis of Zcash, and then also do network security stuff like alternative and stale blocks, potential double spend attacks, which is trivial to see in the transparent pool. It's speculative in the shielded pool because you can see that the nullifier is different, but you don't actually know if it's going to a different address. A little bit of speculation there. And then selfish and stubborn mining detection, and then do advanced studies of kind of network propagation, connectivity, centralization, all of that. Okay. So we finished building the observatory node, and we ended up adding RPC commands because we thought that would be the easiest way for other developers to interact with the observatory features. If you have other suggestions, please let me know. But what we've done right now is we've added it via an RPC, and so you can do list forks, and it will show you exactly where we had differences in the blockchain. You can do detect double spends, and it'll show when there is a fork, it'll compare the transactions between them, highlight any transactions that showed up in one version but not the other, and then do that kind of analysis of like, if it is a transparent pool, does it go to another one? If it's a different hash, does it have a different nullifier? All of that. And then lastly, we have a way to detect selfish mining. And just to recap a little bit how that works, normally a selfish miner will ignore blocks that are broadcast until they solve 2 blocks, and then they'll broadcast both of those at the same time. The signature for that is that you'll see 2 blocks received almost simultaneously with the child. This is based on network timestamps, not the miner timestamps, right? Miners can put an arbitrary timestamp within some bounds into the block. Never trust those for analysis. This is based on actually when we receive the blocks. And then we have like an adjustable threshold for what we want to say, like flag this as selfish mining. With the RPC, you can do detect selfish mining. It'll show you the heights at which these occurred, kind of which blocks were involved, the time to the next block. And you know, if you run a mining pool or something, it might be worth running this to make sure that you're not getting pushed out more often than not. I think this would be an interesting way to detect if any of the major pools are doing selfish mining. We should be able to surface it through here. Okay, global analysis. So how does a single block propagate? Now, on back in May, I only had like 1 observatory node. Now I have a network of them in North America, Europe, Asia, and I forget where the other one's at. And we brought all of that data together. So now we're monitoring, like, depending on the day, there's 180 to 220 full Zcash nodes. There's kind of a decent amount of churn. And we look at when a block is broadcast, how quickly does it propagate? And we see that this is a cumulative distribution function, that most of the blocks, most of the peers receive a block within a second or so. And then there's kind of this long tail of, nodes that went offline for a couple seconds and stuff like that we don't really worry about. And then we looked at, over each block. So here's a scatter plot where the x-axis is the height, the y-axis is the propagation time. Each dot represents a block. And you can kind of see the distribution here. I personally prefer histograms to scatter plots. So if we take this data, we project it down onto the y-axis and then look at broadly what does the propagation time look like. Again, we see that most nodes receive things sub-second, and then there's kind of this tail leading up to about 5 or 6 seconds for some of the blocks. But that's pretty rare. This is a log axis for y, so halfway down is pretty small. Okay, and then status update. So for the solo node, we've completed that project. We made a PR back to the Zcash code base so that anyone can integrate this. Like I said, showed how to use it. This is completely funded by the Zcash Foundation. Very grateful for that. Then we started working on the data aggregation. So we have we integrated WebSockets into Zcash, actually. We can make a PR back for that if that'd be useful. And then we are also operating the Global Observatory Network. And then what we want to do next is we want an open SQL research database that anyone can use. And we would love to have a dashboard front end so that all these plots I'm showing are just like an interactive thing that anyone can play with. But we need to find funding in a week or 2 to make that happen. So if you're interested in having the research database in the front end, please reach out to me. We have options for shielded sponsorship, happy to take fiat. I'm also looking for beta testers and just generally advice on how we should build this. Thank you much.
Awesome, thanks. That was good timing. Cool, so that's all of the presenters who signed up, but I heard this morning that there might be somebody from the ZACT Hackathon project. Nestor, hi, does your mic work? Hello, do you want to give a 5-minute presentation?
Sure. Well, thank you so much for the opportunity to present, and also thank you so much for the opportunity to participate in this hackathon, the GitHub hackathon that was made with Zcash. So I would like to share my screen. First, I would like to introduce the project with a brief explanation. It's a 2-minute video for you to see what it's about, what we are proposing. We are proposing a mobile application for implementation of memo transactions in a social issue. So let me send screen.
Citizen protests for lack of democracy, inequality, discrimination, and an endless list of social injustices are at a dangerous point. Around the world, several are examples of civil protests shut down by police, military, or paramilitary forces. A common factor of failure of these shutdown procedures is the security in its communication mechanisms. For this weak link in the chain, we propose the use of 2 layers of security: geofencing barriers and zero-knowledge snark shield memo transactions. To explain how the app works, we will mention the workflow from 2 different perspectives: creator and attendee. By default, when the user installs the app, it will start as an attendee, having the option to view the available events to attend. But if he wants to publish one event, he will need to go to the Information tab and become a creator, adding the seed phrase from a Zcash shield address with available funds. This information will never be shared and will always remain in the device. Now, to add an event, you will need to add first a title and public information. Then you will receive the 2 last words of the seed phrase generated of the event Zcash shield address that we will use to send secure messages. As a creator, you will need to put these words on a public place inside the area of the meeting point. And finally, you can send as many memos as you want, having in mind the only message the attendee observes will be the last one. For the attendee, the workflow is simpler. You will open the tab and view the available events. If you are interested in one, you will be able to view the title, public information, and meeting point. Once you arrive at the place, you will need to add the missing words inside the geographical area delimited in the map via the geofence requirement. Then, once the seed phrase is complete, a synchronization with the Zcash blockchain starts to reveal the last message sent to this address from the creator address. C-Act, location-based, Zcash-backed event planning.
All right. So that was about what is about the mobile application that we are proposing. You know, a social implementation of the Zcash memo transactions. So this is about the repo that I did. So in this repo, we have the video that we just saw it, and the documentation, and a server, a Node.js server, in order to receive the public information that is available. And it doesn't matter if people access to this information, because they need to go to that place in order to have the 2 final words that are the seed in order to read from the blockchain. So also we did a Gitbook page with explanation about the context, why it's useful to implement this kind of technology using memo shield transaction and the workflow. And also explain how to install the server and the Android application using the Zcash libraries, and how to initialize it and how to read the transactions. And well, yeah, that's about the mobile application. Here's the code. Basically, for instance, we are seeing here how to get the information, how to get the last memo sent to the address of that event created. So we are having here, if we click on this event, we enable this part of in a card view, and basically what we are gonna be seeing here, it's the memo content of the last transaction sent to that address, and we create one address per event. So that's the code, and yeah, thank you so much for the opportunity. And we are also here in the Community Choice Award with C-Act.
Can I ask you a
Cool,
question?
thank you. Hang on, let's let's transition to the Q&A section. Thank you so much for that presentation.
Thank you so much.
Yeah, so the main thing is, if we are recording, I'm not sure if we traditionally stop it before Q&A and conversation.